All right, today's lesson is just final exam review part 1. So getting you guys prepared for the written portion of the fall final exam. All right, so first just the instructions. Please show all work, simplify all radicals, use prime notation for the resulting image in all transformations. All right, so looking at this first problem, this is an angle relationship problem. I'm telling you that two angles form a linear pair. So right away, I know that linear pairs are always going to be supplementary. Their measures must add to 180 degrees. Okay, we're told that the measure of the first angle is 15 degrees less than 2/3 the measure of the second angle. So we're defining that first angle as 15 less than 2/3 the second angle measure. So my second angle, right, that measure I'm thinking of as my x. So if I look at measure of angle 1 versus measure of angle 2, measure of angle 2 is going to be x degrees. And then measure of angle 1, right, 15 less than 2/3 that second angle. So I'm saying, well, that's got to be 2/3 of x, and then take away 15, and then degrees. All right, so I've defined both of my angles. And if I want to visualize it, maybe I take a moment and I visualize it by drawing myself a linear pair. So here's my straight angle, 180. And then I'm just subdividing, and I can never do this to scale because I don't know what it's going to look like till after. So I'm just drawing myself a linear pair that's being split into two smaller parts. And I'm just calling this one angle 1 and this one angle 2. And angle 2 is my x. So here's x degrees right there. And then angle 1, right, its measure is going to be 2/3 of x, take away 15, and then degrees. All right, so I'm visualizing it. I see that collectively their measures, they have to add up to 180. So I can build my equation, right? I can say that 2/3 of x minus 15 plus x, right? The two measures together are going to add up to 180 degrees. Okay. So then from here, right, I'm just solving my equation. So maybe I add the 15 over to the other side first. So 2/3 of x plus x equals 195. We know that's degrees. Now from here, I would choose to clear my fraction. So since I see a 3 on the bottom here, I'm going to multiply every single term by 3. Right, I'm always balancing out my equation. What I do to one part, I do to all three. All right, so if I have 3 times 2/3, that's just 2. So 2x plus 3x is going to equal 585. So now combine those like terms. 5x's are going to add up and equal 585. Okay, and then here I'm just going to divide by 5. And I end up with x as 117. So the measure of angle 2 is going to be 117 degrees. Okay, and then if I'm looking at, well, what is 2/3 of 117? And then take away 15, right? I get 63. And that makes sense because together, those two angle measures need to add back and get me equal to 180 degrees. And these two are absolutely supplements. They do get me back to 180 degrees. So we're good. Okay, next one here, we're looking at two pathways that run parallel. So these two lines are parallel. Let me add in my little arrows to show that. And I'm saying use this information to solve for x and for the measure of angle 1. So first thing that I'm really looking at are these two angles here and what kind of angles they are. So they are on opposite sides of the transversal, so alternate, and in that exterior space because they're outside of the parallels. So these are alternate exterior angles. Let me just write that. And the relationship is that they are congruent. let's say that I blanked on the language, I can still picture how they're related, right? So I can picture how this angle could slide into its corresponding position right here, and then they'd make a vertical angle pair, so they'd have to be congruent. So the equation that I'm going to build is one of congruence, right? The angles are congruent, so the measures will be equal to each other. So these two expressions, right, they have to be equal to each other because the angles are congruent. All right, so here we go. X squared minus 10x minus 14, that measure here, will equal this measure here, negative 15x plus 10. All right, so I've built my equation. I see that there's a quadratic term right here. So I'm going to pull everything to one side so my equation is set equal to 0. So I'm going to add 15x to the other side. I'm going to take away 10. So now I have x squared plus 5x minus 24 all equal to 0. So now I see that it's a factoring problem where what I'm really visualizing, and sometimes it helps to see it, I'm looking for a product of 1 times negative 24, so negative 24, and a sum of 5. So I want two numbers that multiply to a negative 24 right here that add to a positive 5 right here. And hopefully we're able to see that that's got to be an 8 and a negative 3. So if I double check that, it multiplies back to the negative 24 and it adds to the positive 5. Looks great. So my factors end up being x plus 8 times x minus 3 all equal to 0. And as I solve, I'm just taking each factor, making it equal to 0, and solving. So I get that x could be negative 8, x could be positive 3. So now I need to plug back in and see if they both work or if only one of them works. So if I try right here, the negative 8. So negative 8 to the second power, right? I know that's 64. Minus 10 times negative 8 minus 14. That gets me a measure right here of 130. And if I check that here, negative 15 times negative 8 plus 10, here also 130. So that one definitely works. X can be negative 8. It produces an angle measure here of 130 here and here. But since I want the measure of angle 1, I can see that it has to be the supplement of 130 because together they form a linear pair. So the angle that I want would be 50 degrees. Okay, I still have to check the 3. So if I plug in the 3, let's say that I plug in right here, negative 15 times 3 plus 10. Ooh, I see a negative angle measure. So right away I know that this is an extraneous solution, right? Because it produces a negative angle measure, which is not possible. So I'm just going to go ahead and cross it out, right? I could solve for it, but plugging it back in, it just does not work. So the only solution that works here is the negative 8. It produces an angle measure here of 50 degrees. All right, next skill right here. All right, so here I'm saying, let's identify the transformation as a translation, reflection, or rotation. Describe the specific effect of the transformation. Here are the endpoints, right, of the triangle. Then transform it, draw the resulting triangle, label the image and pre-image using proper notation. So here we're presented a rule, and maybe you see it as a rotation, maybe you don't. Let's imagine that you don't for a moment, and you think, well, let me just plot the points. Let me apply the rule, plot the points, and see where my figure lands. So here, if I look at the original points here, what's happening in my rule is the x and y are switching position, and all of the original x values, right, we know that they're switching to the opposite sign here. So let's say that I transfer down the original J, O, and B. Right, J is at 0, 6, O is at 2, 1, and B is at 5, 4. Okay, and then right beside it, I'm going to have my J prime, O prime, B prime. Okay, so remember looking at the rule, right? The y, the original y is going to go first now. So all of these points here, all of those coordinates, sorry, of these points are going to go first. Let me make sure we're in focus really nice. All right, I think that helped. All right, so here I'm going to look at 6, 1, and 4 first. Okay, and then I'm taking all of these original x values and just switching to the opposites. So here 0 stays 0. 2, positive 2 becomes negative 2. Positive 5 becomes negative 5. All right, so I have all of my new points. I'm going to go ahead and plot them. So 6, 0 puts me right here. Okay, 1, negative 2 puts me right here. Let me just label as I go. This was J prime. This is O prime. And B is at 4, negative 5. Right here. Here's my B prime. Okay. And then I use a straight edge. So I get my ruler out and I connect those dots. And I have my resulting image. And I'm showing that with that notation of the primes, right? J prime, O prime, B prime. So now when I'm saying what specific type of transformation it is, right? Translation is out, right? Because I'm not just sliding it left, right, up, down, and keeping the same orientation. I can't draw a mirror line or a line of symmetry, right? So the reflection is out. This is a rotation. And if I picture the origin as my center of rotation, right, I can see that everything has moved 90 degrees, right? And going to the right, to the right. So this would be 90-degree rotation to the right, which means it's going with the clock, which means it's clockwise. Right? To the right, going like that, going with the clock. So a 90-degree rotation clockwise. All right, let me make sure we're in focus again. All right, we look good. All right, so then let's move to the next one, 4. So perform the composition of triangle GAP with the following endpoints. We want to do a translation first and then a reflection second. And then I'm asking you if this is a glide reflection, and then you tell me why. All right. So first we apply the rule for the translation. So it's saying let's go 4 left and then 4 down. So if I start with the G, I'm going 4 left, 1, 2, 3, 4, and then 4 down. Right there. So there's my G prime. Okay, my A, 4 left, 4 down. Here's my A prime. Okay, my P, 4 left, and 4 down. Right here. Here's my P prime. Okay, connect the dots. And the first part of the composition is done. All right, translation part is done. And as I'm working through this, I always want to make sure that my figures still look congruent, right? So every rigid transformation, our figures are always staying the same size and shape. We're just altering the place and position on the coordinate plane. So now I build off of here the translation, and now I'm going to reflect it in the line across the line y equals x. So if I graph the line y equals x, right, I start at the origin and I go up 1 over 1, right, up 1, right 1. And I'm just going to go ahead and graph that so I see my mirror line right here. All right, so that's my mirror line. That's my line of reflection, y equals x. Now, let's say that I want to think of that as a rule. That is x, y, arrow to the right, y, x. Right, the x and y's just switch position. That is it. But maybe I forget how that works. Maybe I forget the rule. I can also think if I go from G prime first, I can think, well, how far away is it horizontally to the reflection line? And then go vertically, right, away from that mirror line. So if I look at where G prime is, here I'm 9 away, and then 10, 11, 12, 13, 14. So then here I'm going here to the x-axis. Okay, so I went here, that 5, and then I'm going down another 9 to right here. So here's my G double prime. But again, if I remember the rule, I can just think of, well, what is this as a point? So that point is at -9, 5. So if I just switch that, I'm going 5, -9 right here. So there's my new G double prime. Okay, for the A prime, here I'm just 7 left, 2 up. So if I picture that point as -7, 2, then I'm 2, -7 right here. Here's my A double prime. But again, the other thing that I could do is count 7 to the y-axis, 8, 9. So horizontally, we're 9 units away. So I need to be 9 units away vertically away from it. Okay, for the P prime here, right, we are 4 away, and then 5, 6, 7, 8. So I need to be 8 away. Here's 4, 5, 6, 7, 8. Right there, there's going to be my P double prime. But again, I could have looked at that location. So -4, 4, and gone 4, -4 to plot the new point. So there's a couple options for how you plot it. Let me connect the dots. Okay, and then that looks good. All right, so I have it in place, and a good way that I can check that I've done it correctly, right, I can always connect the P's like that, right, and I can show that that mirror line is really the perpendicular bisector of the segment that connects the P's. Same thing with the G's, and then same thing with the A's. So all looks great. I'm in the right spot. Okay. Last thing to do is answer if this is a glide reflection. So if it's a glide reflection, that means it's some combination of a translation with a reflection, right? The order really doesn't matter. But we have to see that the translation pathway, the vector that's moving this figure to this figure, has to be parallel with our mirror line. So let's say that I draw in one of the vectors like so. Right, that does run parallel. There's the same slope for that pathway as we're seeing right here. So they do run parallel. So we would say, yes, this is a glide reflection. Right, it's a translation with a reflection. Okay, and that vector or that translation pathway is parallel to the mirror line, right? They had the same slope, they ran parallel. Okay, and then what that really tells us is that we could have done this in a different order. So I could have reflected it first and then translated it, and I would have ended up in the same position. So it is a glide reflection. So a combination of translation and reflection, either order. The translation pathway runs parallel to the mirror line, right? We could have done it in either order, ended up in that same exact spot, right? The classic image that we use for this one is we say, think of the footprints, right? It's just like footprints. That's a classic glide reflection. All right, next one here, I'm saying find the area of this triangle with these endpoints. So the first thing that I would think when I look at this is this a right triangle? It's a question I would ask myself. Is this right? How would I know if it's right? Well, I know it's right if my slopes, if I can find a pair of slopes that are opposite reciprocals, right? Those would be perpendicular pathways that would create a right angle. So if I look at AJ for a second, and I'm looking at its slope. So here I'm going up 2 and right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up to right 10, right, reduces to be 1 over 5, 1/5. The slope is 1/5. So then if I look over here at JW and I want to see what its slope is, I want to see that it's an opposite reciprocal, because then this would be right triangle. So here I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and right 2. So down 10, negative 10 over 2 reduces to be negative 5. So we say, yes, this is a right triangle because these two segments, they have slopes that are opposite reciprocals. So we know that AJ must be perpendicular to JW at point J. So what I love about a right triangle is that I can use the legs to solve for the area, right? Because my area for any triangle is 1/2 base times height. So I can use those two perpendicular sides to figure out my area. So first I just need to get to the measure of AJ, right? So it's the hypotenuse of this right triangle. And then I need the measure of JW, again, the hypotenuse of this right triangle. Okay, so if I look at one of them, let's say that I look at AJ, right? It looks like this, where this is 2 and this is 10. Right, I'm just looking then for the measure of the hypotenuse, which is this segment right here. So I know that that's really a squared plus b squared equals c squared, right? But my shortcut is to just go straight to the hypotenuse. So the square root of 2 squared plus 10 squared. So here I have 4 plus 100, which is 104, square root of 104. So when I think about that, that is 4 times 26, right? 26 is really 2 times 13. I'm not going to get any pair out of that, but I will get a pair of the same thing out of that 4. So I can see that its measure is 2 root 26. So right here is 2 root 26. Now when I look at this triangle here, right, where I have it kind of marked off like so, right, that leg is 2, that leg is also 10, so the hypotenuse will be the same thing. I'll also have a 2 root 26 right here. So my legs are both 2 root 26. Now with area, sometimes it's tricky for people to see, but just a reminder that if I look at my triangle as drawn, right, like this, where these are both 2 root 26, right, where this can be my base, this can be my height, it's just the same thing as if I rotate it and look at it, where I have a base that's horizontal and a height that's vertical, right? They're still just 2 root 26. So when I'm solving for area, right, let me tuck it here. Area is half base times height. So half of 2 root 26 times 2 root 26. That's like saying half of 2 times 2. And the square root of 26 times the square root of 26 is just 26. So then times 26. So half of 2 is just 1. And then 2 times 26 is going to get us just 52. So 52 square units right there. Okay, one other way that you could do it is you could say, well, what if this is my base? Well, that's fine. I can find my base measure using the same method, Pythagorean theorem. And then if I find the slope here, I know that I could find then the opposite reciprocal and connect from J to the base, right? To find the altitude, its measure would be the height. And I could do 1/2 base times height that way. Or I could frame this as a big rectangle, find the area of the rectangle, and subtract the 3 right triangles. That's another method, and I really like that method to double check. All right, last problem. Find the shortest distance, so the shortest distance from a point to a line. And the shortest distance is always going to be the perpendicular pathway. Perpendicular pathway. So I have to make sure I can first plot the point. So -3, -10. Okay, and then I'm looking at the line. So the line here, I see it in standard form, right? AX, BY equals C. So when I see it in standard form, I usually like to graph it using the intercepts. So if I'm looking for my x-intercept, that's when y is 0. So if I plug in a 0 here, I'm really solving 4x is equal to 20. And when I divide by 4, I get that x is 5. So x is 5 when y is 0. And if I want my y-intercept, I can plug in 0 for x, cover that part up, divide each side by 5, and I get that my y would equal 4. So when x is 0, my y value is 4. So I have my intercepts at 5, 0, right here, and 0, 4, right there. So here, I can see that my slope, right, is down 4, right 5. So down 4, right 5, -4 over 5. Okay, let me just give myself a few more points off of that. So down 4 and right 5. Okay, and then I'm just going to connect my dots and draw in that line. Okay, so I have my point, I have my line, and now I need that shortest distance that connects them, right, which I know is the perpendicular pathway. So my perpendicular slope is the opposite reciprocal, so 5/4. So I'm going to connect the two. So I'm going to say, okay, from this point, I'm going to go up 5 and right 4. Up 5 and right 4. Makes contact right here. So when I connect those right here, that is what I want to solve for. So I have these two endpoints, right? I want the length of that segment. So I could use the distance formula, that's fine, or I can do what I've been doing all along, is visualize this as the hypotenuse of a right triangle. Now it took me 2 slopes to connect them. So when I visualize that triangle right there, 2 slopes, that means that horizontally they are 8 units apart. Okay, and vertically they are 10 units apart. So here I'm looking at the square root of 10 squared plus 8 squared. So square root of 100 plus 64, which is 164. So 164, let me look at that. That's 4 times 41. And that 4 will give me a pair of 2's, but I'm not going to have a pair in that 41. So it's just going to be 2 root 41. 2 root 41. All right, that's our review for the day. Have a good rest of your day.